Hash functions have several essential properties that make them effective and reliable. First, they should accept inputs of potentially unbounded size. This means you can input any amount of data, whether it's a single word or an entire database, and the hash function will be able to process it. However, the output is always of fixed size. For example, whether you input a 100-byte file or a 100 megabyte file, the hash function might always output a 32-byte result. This fixed size is key to ensuring efficiency and ease of use. Another important property is speed. The function needs to be fast to compute. When working in cryptography, we want operations to be quick and efficient, so hash functions should ideally not be computationally expensive. An important property of a hash function is that it must be a one-way function. In other words, while it is easy to compute the hash from the input, going in reverse, that is, figuring out the input from the hash, should be nearly impossible. Many times we want even more, for example, pre-image resistance. This means that even if someone controls an input, like the word blockchain, they shouldn't be able to find another input that results in the same hash. Even more ambitiously, we might want what is called collision resistance. We don't want it to be easy to find two different inputs that produce the same hash output. This is important, for example, when we use hashes to ensure data integrity.